Hi there, Physics 131. I want to go through just an overview of the reading today I'd like you to do. It's finishing up Chapter 3, so 3.7, 3.8, 3.9. 3.7 is just a bunch of actual examples of how you solve problems using Newton's laws. The first one is actually about a real guy. You can look this up. There it is, a New Scientist article from 2007. Death Special, a skydiver's worst fear. New Zealander Michael Holmes describes the moments before he hit the ground at 130 kilometers per hour. So it talks about his parachute failing. Mild panic set in. I shouted into the helmet camera we'd been using to video the whole experience. Oh shit, I'm dead. Bye. Okay, so it's real. But what you do in the problem is step through the whole process, sketch and translate. Simplify and diagram, represent mathematically, so use Newton's second law to solve out, and then solve and evaluate. So you end up with, he gets a 390 Newton upward force on him. So, okay, and then there's an elevator ride on a bathroom scale, so you can work through that. Again, all the problems in this textbook sort of go through the same sort of 4 steps. Sketch and translate, simplify and diagram, represent mathematically, and finally solve and evaluate. And I mean, I would seriously recommend trying to do your problems in this way. And this way you've got some structure and you kind of have an idea of what to do. Section 3.8 is just an overview of how Newton's third law comes into play. That's that equal and opposite forces on 2 different objects. So this is a nice little experiment kind of showing you where this is coming from. There's a testing experiment where you can test Newton's third law. You can try to be convinced of its validity. So here it is in equation form. The vector force of 1 on 2 is equal to negative the vector force of 2 on 1. It's as simple as that. But you should definitely read through this, try to go through here's a question, a book sits on a tabletop, identify the forces exerted on the book by other objects. And then for each of these forces, identify the force that the book exerts on the other object. So I would recommend you go through that. There's a hairdryer example. Hairdryer is sitting on the scale. What are these interaction forces that are equal and opposite? And then there's a nice little description of linearizing data, which is exactly something that you're going to be doing in practicals. And the last section of Chapter 3 is about seatbelts and airbags, which is a very, very practical consideration. So why does an airbag pop up when you crash into something? So first of all, it spreads the force out over a larger area, so you're not just hitting the steering wheel or hitting a small little part of your car, which could puncture you. But second of all, if you think about this, you've got you have to slow down a certain delta V, and that's given. Whatever speed you were going, you have to stop if you hit a tree or something, or a stationary object. But if you increase the stopping distance over which the force is acting on you, because you're going into a squashy bag, as opposed to a hard piece of plastic like the steering wheel, then that can decrease the value of the acceleration as you go over that distance, and therefore reduce the average force that is acting on you to stop you. And so there's a whole example of how you actually find that force given the acceleration. And then there's a nice little summary showing the main ideas and equations in this chapter, the Newton's 3 laws, and there's questions and problems, and that's it for reading overview for today. Okay, bye for now.